Hello 108 students, welcome back to section 7.1. Mr. McHugh here with you. I'm going to tackle page 2 and we're going to go ahead and work with our first simplifying of a rational expression. Okay, now this idea requires us to remember that you can factor polynomials. So you want to look at factor both the numerator and the denominator. Think of the Berlin Wall, the north half, the top half, and the bottom half. You want to factor those so that you have multiplication, so you're converting from addition, subtraction to multiplication. And finally, you're looking for the moment when you have like products stacked on top of each other and you cancel them out because they equal 1. Okay, so let's just go ahead and take the first example here, 2b I picked on, and this is a rational expression again because you've got division, you've got that fraction bar, and you've got a polynomial up in the numerator and 1 in the denominator. The secret to doing these is simply realize, again, the fraction bar is like the Berlin Wall. Factor the numerator. Now, I think in this section here, I'm not going to go through all the gory details of how to factoring. That was chapter 6's responsibility. So you'll notice my notes, I used FOIL technique. Okay, so a squared minus a plus 6. If you factor it properly, you get a minus 3 times the quantity a plus 2. Okay, then you take the denominator and look at that trinomial and factor it into a plus 3 times a plus 2. Okay, now I just want to highlight you've got nothing but multiplication going on between these 1, 2 factors in the denominator, 2 in the numerator, and then this is a special moment here, and bear with me, I tell a story about Teenage Mutant Ninja Turtles, and I usually get help because I get them mixed up, but Raphael or Leonardo or Donatello, one of them has a ninja size, and they are the weapons that look like this. And there's a little handle right here and they held on to them. I want you to take your size out and very carefully use them and try to have some fun here because you're going to be doing a lot of work here factoring. This is the moment when you have anything, any factor divided by itself, you can cancel it out because it equals 1, and 1 times anything does not change the value. And that's what that last property was trying to get you to see. So anything divided by itself equals 1. Thus the answer here ends up being a minus 3 divided by a plus 3. Now, if they ask for restrictions, if they do, you take the denominator, a plus 3, and you set it not equal to 0. This expression in the denominator cannot equal 0, so therefore minus 3 on both sides, and a cannot equal negative 3 if they ask for that. Now that's not part of this problem, but keep it in mind if they ever do. Okay, now let's go on and pick up the pace here a little bit. Let's look at example 2c. Y squared minus 4. Now I made a big deal about this. You say, can you factor this? And you need to see, class, it is the difference of squares. So the answer is yes. Okay, can you take the square root of y squared? Yes. Stick it in the first slot. Can you take the square root of 4? Yes, it's 2. Stick it in the second slot. Give yourself a minus and a positive, or do it the way I taught it before. Write the conjugate. Whatever way works for you. Okay, now you look at 2y plus 4 down in the denominator and you go, oh, I can't factor that, and you have to remember rule number 1 is what? Yes, pull out the GCF. Look at the 2, look at the 4. Pull out a 2, you're left with y plus 2, and time to pull out your psi, cross them out, like factors, and finally you're left with y minus 2 in the numerator divided by 2, and you got it. Okay, so we're cruising. You're getting the general idea of it. Sorry, I moved it, but I don't want to yet. Look at example 2f. 8 plus k divided by 16, and you're like, you try to factor it, and you look at the numerator, and you go, I can't pull anything out. Nothing to factor. It's already simplified. 16, you could say 4 times 4. Bottom line, you can't simplify anything else, so therefore it's already in lowest terms, and that's your answer. You'll get 1 or 2 like that. Okay, now we get to example 3a, and hopefully from your 025 days you remember this. Now, unless you had me, this next phrase is as a concept I came up with to understand what happens if you have a variable such as m minus 3 divided by 3 minus m. Now when I look at this, I intuitively cannot see and tell you what this is going to reduce to. Now I'm going to walk through the steps here and I'm going to explain what the Texas Longhorn flop is. Now This is my first time doing this without a whiteboard and you guys looking at my hand, so I'm going to ask you guys to bear with me, and I think I'm going to make a whiteboard video so you can kind of see this in action here, so look for that. The Texas Longhorn flop came to me when I was teaching my very first semester of this back in the fall of '09, and I had a student staring at me. He had a Texas Longhorn hat on. Now, I'm not going to draw the correct symbol for it, but if you look at the Texas Longhorns, they're based in Austin, Texas, and my grandson Sam lives down there. He's 9 months old and he's starting to dance already. He was dancing video of him here. You know how the Longhorns have got those big longhorns to them. They're cattle. Okay, now I'm not doing a good job of drawing it, but that's the symbol that's on the hat, and it reminded me of Texas football is big, and their fans are passionate, and they like to stick out their hand, and you can't see me doing this, but grab your two middle fingers and hold them with your thumb and stick out your pinky and your pointy finger, and that is the hook 'em horn sign. So try imagining sticking that up with your right hand and sticking it with your index finger on the M and your pinky on the 3. And I want you to see this pattern where the subtraction is your knuckles. Now if you pick this up, flip it and rotate it, and so put it back down on the board. Hopefully you're trying this. You'll see the video. Pick it up, flip it. If you match the pattern, meaning now that your pinky is sitting here and your index finger is sitting here, you have the Texas Longhorn flop, and the shortcut is, I'm going to prove it to you, it equals -1. Now you would not know that unless you memorize it, and I'm going to show you why here in a second. Okay, so I want you to learn this Texas Longhorn flop. It'll save you lots of time, and you'll be in great shape. So hopefully you see, match the pattern. You must have subtraction. Now the other thing you might see here is look at the M and look at the potential diagonal. When you see the variables are like in a diagonal position and you've got subtraction, you also can tell yourself you've got the Texas Longhorn flop, and it simplifies down to -1. Now how does that happen? Okay, now here we're going to do some hocus pocus. I'm going to leave the numerator completely alone. And what we're going to do down here in the denominator is 3 minus m. I am going to pull out a -1. Okay, now the crazy thing is, you go, well, why are you doing that? Well, because what's going to happen here is when I pull out a -1, I'd have to multiply by the parentheses -3 plus 1 to get 3 minus m. Okay, now then what happens here is there's another step I needed to add here. I need to fit this in here. I'm surprised I didn't stick it in my notes. Inside the parentheses, bear with me. Does everybody see inside the, well, I did do it here. See inside the parentheses, you've got the plus sign. Addition is commutative. It doesn't order the matter. So now instead of the m being the second term, I'm going to make it the first term, and then a -3 is going to be the second. So -3 plus m is equivalent to m minus 3. That's the big key step right there. Okay, make you jump through a lot of hoops to set this up so that all of a sudden you realize you have m minus 3 as a factor in the numerator and in the denominator, and you can cross it out because it's equal to 1, and look who's left standing, -1. 1 divided by -1 is still -1. Okay, so that is the Texas Longhorn flop. So you can remember the flop, or when you see the diagonals are equal and you have subtraction in numerator and denominator, the rational expression is equal to -1. Okay. In the book, they I think they try to use this crazy x minus y divided by y minus x. Again, see the flop. I see the diagonals. Try to match up the Texas flop, and you got simplifies down to -1. Okay. Class, we've done that. I hope you like that Texas Longhorn flop. I hope you remember it. I think it'll help you remember something that if you only leave it in your short-term memory, it's going to disappear. Okay, so I'm hoping this crazy phrase, and you watch the video, you see me flopping my right hand back and forth and rotating it, and you see that, you'll remember it. So I'm going to say that's all for now. I'm going to check off here on page 2, and I will see you for page 3. Okay, goodbye.